Every star you see was born. Every star you see will die. This is their story. In the darkest clouds of gas and dust, where light cannot escape, stars are waiting to be born. The Eagle Nebula, a cloud so vast it contains enough material to create 10,000 stars like our Sun. The Pillars of Creation, where stars emerge from the cosmic womb. Each dark globule hides a star being born. Gravity takes hold. The cloud collapses. In 100,000 years, this darkness will become a blazing star. A protostar ignites, not from fusion, but from the crushing weight of its own gravity. Stellar jets blast through the cloud at 300 miles per second, announcing a star's arrival. A T-Tauri star, an infant sun, chaotic and violent, not yet settled into its adult life. Around the young star, a disk of debris. From this chaos, planets will be born. The core reaches 10 million degrees. Hydrogen atoms fuse into helium. A star is born. The main sequence, where stars spend 90% of their lives, stable, steady, shining for billions of years. A star's mass determines its fate. Small stars burn for trillions of years. Massive stars live fast and die young. 4 hydrogen atoms fuse into 1 helium. The missing mass becomes energy. Einstein's equation powers the stars. In massive stars, carbon, nitrogen, and oxygen catalyze fusion. The same fuel, but burning thousands of times faster. Gravity crushes inward. Fusion pushes outward. The perfect balance, a star at peace. After 10 billion years, the core runs out of fuel. The star's long summer ends. Autumn begins. The star swells. Its surface cools. A subgiant, neither young nor old, but changing. The star becomes a red giant, 100 times larger, 1,000 times brighter, aging on a cosmic scale. Betelgeuse, a dying giant so large it would swallow Jupiter. Soon it will explode. The core ignites in a helium flash. For a few minutes, the power of an entire galaxy buried in a star's heart. Helium fusion grants a reprieve, 100 million years of stability, but the fuel won't last. The star swells once more, larger, cooler, dying. Powerful winds strip away its outer layers. Thermal pulses shake the dying star, violent flashes every 1,000 centuries, each one stronger than the last. The star sheds its skin, a beautiful death shroud expanding into space. The end is near.
The Ring Nebula, a stellar ghost, the final breath of a star like our Sun, frozen in time. A white dwarf, Earth-sized but heavy as the Sun, no longer burning, just slowly dying embers. Sirius B, a white dwarf orbiting the night sky's brightest star, a glimpse of Sirius A's future. White dwarfs cool for trillions of years, slowly fading to black. The universe isn't old enough for any to have died completely. As white dwarfs cool, their carbon cores crystallize, stars becoming diamonds, cosmic jewels forever. For stars like our Sun, this is the end. No explosion, no drama, just a slow fade to darkness. Massive stars burn blue, white, and brilliant. In 10 million years, they'll exhaust their fuel and die catastrophically. Like an onion, the star burns in layers, each shell fusing heavier elements. At the center, iron, the end of the line. Iron cannot fuse. The star's energy source dies. In seconds, the core will collapse. The core collapses, crushed to the size of a city in 1 second. The star's death begins. The core bounces like a cosmic spring. A shock wave races outward at 20,000 miles per second. Supernova, the most powerful explosion in the universe. For a moment, one star outshines an entire galaxy. The Crab Nebula, remains of a supernova from 1054 AD. At its heart, a pulsar spinning 30 times per second. A neutron star, the core compressed to a city-sized sphere, a mountain's weight in every teaspoon. Pulsars, spinning neutron stars sweeping radiation beams across the cosmos, nature's most precise clocks. Magnetars, neutron stars with magnetic fields so powerful they could erase your credit cards from the moon. The most massive stars, rare cosmic titans, so unstable they erupt violently before their final collapse. The most massive stars don't leave corpses. They explode so violently nothing remains but expanding gas. Hypernovae. When the most massive stars collapse, they fire jets at near light speed, gamma-ray bursts that could sterilize planets across the galaxy. When even neutrons cannot resist, the core collapses into a black hole, gravity's ultimate triumph, a point of no return. Mass determines destiny. Small stars fade gently. Medium stars explode violently. Massive stars collapse into black holes. In the Big Bang, the universe created hydrogen and helium. Everything else, carbon, oxygen, iron, would require stars. Stars are cosmic forges, creating every element in your body. We are literally made of stardust. Carbon, nitrogen, oxygen, life's essential elements. Created in dying stars and scattered across the cosmos. Stars build heavier elements step by step, adding helium nuclei like cosmic Lego blocks. Silicon burning, the star's final days. In a week, it creates iron. Then the fusion stops forever. In supernova's fury, iron captures neutrons so rapidly, it builds elements all the way to uranium. In aging giant stars, slow neutron capture builds heavy elements over thousands of years, the patient path to gold and lead. When neutron stars collide, they forge gold, platinum, and uranium. Your wedding ring was born in cosmic collision. Supernova shockwaves scatter the elements across space, enriching clouds that will birth new stars, new planets, new life. Each generation of stars enriches the next. The first stars had no metals. Our sun is third generation, rich with the ashes of the dead. The sun and earth formed from a cloud enriched by dead stars. Every atom in your body is recycled stardust. Earth is a stellar graveyard. Your iron from supernovae, your carbon from red giants, your gold from colliding neutron stars. You are made of star stuff.
The atoms in your body are billions of years old, forged in the hearts of dying stars. Stars are cosmic recyclers. Dying stars birth new stars. The cycle has continued for 13 billion years. For trillions of years more, stars will live, die, and create. The cosmic forge burns on, building the future universe. Eta Carinae, 100 times the sun's mass, erupting violently. When it explodes, it will outshine the moon. WR-104, a spinning pinwheel of dust, beautiful but deadly. If its gamma ray burst points at Earth, we'll know. R136A1, the most massive star known, 300 times the sun's mass. It will live for only 3 million years. VY Canis Majoris, so large that light takes 6 hours to travel across its surface. A dying hypergiant in its final days. 3 fates await dying stars: white dwarf embers, neutron star remnants, or black hole voids, stellar corpses filling the galaxy. Born together, but aging at different rates. Massive stars already dying, while red dwarfs have barely begun their lives. Globular clusters, ancient cities of stars, 13 billion years old. All the massive stars died long ago. Starburst galaxies, stellar birth and death on fast forward. Stars forming and exploding so rapidly they blow gas out of the galaxy. Omega Centauri, not just a star cluster, but the heart of a galaxy our Milky Way devoured billions of years ago. In 5 billion years, our sun will become a red giant, swelling to Earth's orbit, ending life on our planet. The sun will die peacefully, shedding its outer layers in a beautiful nebula. A white dwarf will be all that remains. The smallest stars will outlive everything, shining for trillions of years. Not a single red dwarf has died yet. Every star you see has a story. Some are being born, some are dying. All are temporary, just like us. We are not in the universe. We are the universe. Stardust that learned to think, to feel, to wonder at its own origins. The cycle continues. Birth, life, death, rebirth. For trillions of years more, stars will light the universe and forge the elements of life. The cosmic story continues.